All right, so we're looking at a couple application problems. So let's read through this one and make sure we understand how this is an inequality. So we've got a ball is thrown upward from the top of a 100-foot building with an initial velocity of 60 feet per second. If the height of the ball is given by that f of t equation. So this is a legit equation. You would use this in physics class for projectile motion. The 60 in here relates to the initial velocity, and the 100 relates to the height of the building, okay? So this equation, if you give a time, it's going to tell you the height of the ball. So notice, if I plugged in a 0, I get 100. Well, why is that? Where's the ball thrown from? Top of a building. And if you were to look at the path of the ball, what type of path does if you throw a ball, will it find? Yeah, but it's thrown which direction? Upward. And so its initial height is here at 100, so it's going to follow that path there. Yes. That's why the equation's a problem, right? So you see how the equation matches the motion of the ball. Okay? Now, here's where we're tying in what we've learned today. It says find the time interval for which the ball's height is above the top of the building. So notice, this tells us the height of the ball. We want this, we want to figure out where is this what? Greater than 100. So this last sentence, you have to read that last sentence and say, okay, I got to take my function and I have to say, I have to solve for t, when is it, oops, not greater than 0, greater than 100. Okay, so this is exactly right. That last sentence is this. Because this tells us the ball's height. Where is the ball's height? Higher than the building? Greater than 100. Not at the height of the building or higher. Since it's got to be higher than the height of the building, we got to do greater than. Guess what you do now? What I taught you today. Now you go through and solve for t using the methodology I taught you today. Go ahead and work on that, and we'll do one more application problem and we're done. Okay. We'll go through this with you. I'm going to subtract 100 from both sides. And that gives us negative 16t squared plus 60t greater than 0. So 100's canceled. I'll then set this equal to 0 and solve. I'm still going to factor. And what can I factor out? What's in common for both of these? Yeah, negative 4t. So that's going to leave with t minus, was
14 minus 15.
Yeah, 14 minus 15, sorry. 14, thank you. All right, and then we set each factor equal to 0, so let's see, we get negative 4t equals 0, so time is 0. Well, that makes sense. So when time is 0, it's starting to go, but now we got to think if we include or not. And then we get 4t minus 15 is 0, so we get t is 15 fourths. So I can still do the same method, but I don't think, I think I know where the test is gonna be. Look, I'm not gonna test here. Why not? Yeah, this isn't Back to the Future. You're not going back to 1985. You can't do this. So you can't go there. And think about it. It's starting at time 0, so it's got to be over this interval here and here. I mean, we can test a 1 and see. So let's see. If we test a 1 is -16 plus 60 greater than 0, yeah. If you tested something out here, you're going to get false. Now, the question is, do I include these ends or do I exclude? Yeah, because it's above. So those are open circles, and there you go. And that's it. So that ties in what we've been doing today. So the time is 0 to 15 fourths. It'll probably say time 1 is 0, time 2 is 15 fourths. From here to here, and it'll say, do you include or exclude? It'll probably put the wording like that. You'll say, I want to exclude. Okay? That's it. All right. One more problem. I know we're ready. We've done a lot, but let's do one more. And we'll be done. Not like this. It's much shorter. It's just domain. Okay? And I'm going to send this video clip out, so if you want to go back through it, you can. But everybody okay with get the idea? All right. So last problem is this. Just basically how am I applying what I've learned today? So this is a fairly, I think simple problem. So the last example, find domain. So you're going to say find domain. What does this have to do with anything? Well, let's say we have y equals square root of x squared. Let's say it's minus 5x plus 6. Okay. Let's say that's our function there. Notice this is a square root. Domain means we're looking for what? What are we looking for? The x that you can plug in. Now, again, rather than me try to graph it and look to see what the x's are, I'm going to think for a second. I know that the inside of a square root cannot be what number? Negative. Can it be 0? Can it be positive? So the inside of a square root needs to be blank or blank than 0. Greater than or equal to, however, I got the blanks right. So all I'm going to do is this. To find the domain, I'm solving for x's again. I need to solve for x. Well, what are the x's? Well, I need to know where is this thing greater than or equal to 0. And if I can figure out the x's that make it greater than or equal to 0, I've got it. And guess what? It's the same problem we've been working today. Polynomial inequality. And this is a quadratic which will factor. So now if you solve this inequality, you have the domain. And that's it. And this one should factor fairly nicely. Get your solutions, put them on the number line, test your points, yada, 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 write your solution in interval notation, and that's your domain. Okay, how did you get it to factor? We got 2 and 3. Put those on the number line. And I'm going to put a closed circle. And I'll test. And I would plug into the factor part. right? I think it's a little bit easier if you plug into the factors for the inequality. Let's see if I plug in a 0, I get a negative times a negative, which is a positive, so you should have shaded here, you should have shaded there. True, or where it was true. If I plug in a 4, I get 1 times 2, 8, or sorry, 1 times 2 is 2. So your domain, and then infinity to 2, bracket, union, 3, 2, that's right. All right, that's the lesson.